we want to do number 20 in the book. So that's the one I was trying to do just in the last lesson on accident when I got too far ahead. So let's go back to that one. We're in section 9.6 of the book. So if you want to open that up, read number 20, just kind of get your feelers on reading the problem first and see what you might think about it. We'll look at it together, and then we'll come back and start the problem. Okay, so each side of a regular octagon, so a figure that has 8 sides, has a length of 2.12 meters. If a circle is circumscribed, so circumscribed means it's going to go around the outside and hit every vertex, what is the radius of the circle? Alright, we're going to draw an octagon, put a circle on the outside, and each side of the octagon has a side that's 2.12 meters. Alright, octagon. So let's do our best at trying to draw one of these things. See, there's one side 2, 3, 4, 5, 6, 7, 8, maybe so. I don't know. As best as I can probably do right now. And then if we take a circle and draw the circle where it circumscribes, so it's going to hit all those vertices just like that. And so what we want to do is find the radius, so the distance from there to there, or there to there. You can see we've got several radiuses. I'm going out to each of the vertices of the octagon because that's where it actually touches the actual circle. Okay? And then other piece of information that we know is that we know that each side, so from here to here, is 2.12. I think they called it meters. Okay, so if nothing else, if we take one of these triangles and kind of enlarge it, we can call that, this is 2.12 meters, and these both sides are equal. Those would be the radius of the circle. Okay? Alright, so if I finished out drawing the rest of the spokes of the circle, we basically have 1, 2, 3, 4, 5, 6, 7, 8. Or we have 1, 2, 3, 4, 5, 6, 7, 8. Get all the way around, you have 360 degrees. We have 8 equal segments. So together, in other words, if you wanted to know how much degrees are in each segment, we're just going to take 360 divided by 8, and it tells you that each segment is 45 degrees. So on our larger triangle, that means that right in there is 45 degrees. Okay? Well, I can easily get these other two angles up here, because if all angles of an interior of a triangle are supposed to add up to 180, and if I subtract off the 45 that I know, that gives you about 135 degrees left to work with. And these have to be equal because the sides opposite them are both equal. They're both radiuses. So this is going to be 67.5, and that one right there is 67.5. Okay, so let's do some math here. Can I find R if I know everything else? Well, I'm trying to find a side, so I'm going to say R over the sine of the angle opposite it, which in either case is 67.5, should equal another side. So we're doing side over angle, side over angle. So the other side is 2.12 over the sine of the angle opposite 2.12, which is 45 degrees. Okay, so R is going to equal, by the time I get rid of the term in the bottom there, will be 2.12 times the sine of 67.5 degrees, all divided by the sine of 45. Okay, we're finding a side of a triangle, so we're only going to get one potential answer here, and we'll get R by the time we plug this in the calculator. And since the only piece of information they gave us is 2.12 meters, let's go to 3 significant digits. So it looks like R is going to be 2.77 meters. Box that up, and we're done with this problem. Okay, let's do the same thing. If y'all want to go to number 26, look at it for a second, and then let's come back, draw ourselves a picture, and get started with the problem. Alright, a vertical watchtower stands on a hillside that makes an angle of 22 degrees and 40 minutes with the horizontal. What that's referring to is the slant of the hill, the steepness of the hill. Okay, and from point P, which is 101 feet directly up the hill, from the bottom of the tower, the angle of elevation of the top of the tower is 4 degrees and 10 minutes. How tall is the watchtower? Okay, so along this large hill, this long hill that we've got going on, you have a vertical watchtower somewhere up above on it, and then 101 feet further up the hill, then you have point P. And the angle of elevation to the top of the tower is 4 degrees and 10 minutes. Okay, let's see if we get a picture drawn here. Okay, so let's make this, I'm going to draw this picture kind of big. Here's the flat ground, and then all of a sudden we're going to have a hill going up. And the slantness of the hill it's not very steep, it's only a 22-degree hill. So kind of like that maybe? Because the steepness would be like right there. 22 degrees, and I believe it said 40 minutes. Alright, somewhere along here we have a watchtower. So I'll call that the watchtower. And then we have point P. Now here's the thing with point P. Let me bring up the problem so I can show you this. Okay. It says from point P, so if you put your finger on point P, then it says that the angle of elevation to the top of the tower is 4 degrees and 10 minutes. So if I'm at point P, hold on. Okay, the screen just kind of went out for me for a second, but okay, so it says if you're at point P, then the angle of elevation of the top of the tower, so if I'm at point P, so even though point P is further up the hill, it says I have to have an angle of elevation to look to the top of the tower. So I have to be looking up to even get to the top of the tower from point P. Okay? So that's very, very, very important. It's a small angle, it's just 4 degrees and 10 minutes. Okay, so if I put, let's say, point P right here, that's a good spot because I have to look up to get to the tower. Remember, angle of elevation or angle of depression, it's always with respect to the horizontal. So you've got to give yourself a horizontal bearing, and then I'm looking up. To get from here to here, I'm looking up to get to the top of the tower right there. And it's just very small, but I'm going to make it a little bit bigger just because so we can see it on the picture. Okay? And then it said it was 110 feet further up the hill. Actually, it was 101 feet. Okay, so let's change this. Okay, so here's my tower. I want to find the height. I know the steepness of the hill. It's 22 degrees and 40 minutes. I know at point P that I am looking still up to the top of the tower. So that's good. I don't want to put point P like way up here because then it'll cause me looking down at the tower. And that would be an angle of depression. We want an angle of elevation. Okay, and we just need to find X. Okay, well, if I can get this whole angle, let me get a different color so we don't get confused here. If I can get this whole angle right here, X is what's opposite all of that. And then opposite of 101 is this angle up here. So eventually I'm going to need both of those angles. So let's see what kind of information I can find or what information I can use. Let me first draw you a picture so you can hopefully see this with me. If I have one line here and another line right there and this bisects it, if this angle, what would that be congruent to? Well, hopefully I'll see it would be this angle right here. Okay. Well, in our picture, what I'm looking at is here's a parallel line to this line right there. If from there to there is 2240, then what this is telling me is there to there is 2240. Okay? So, if I do all my math, then I know this whole angle that's opposite of X is technically, I don't know if we want to call that, we'll just call all that angle right there theta. Okay? And we'll call all this one up here alpha. So we can say that theta is equal to 22 degrees and 40 minutes plus 4 degrees and 10 minutes. So theta is equal to 26 degrees and 50 minutes. And again, that's the angle of the whole side, or the whole angle opposite of X. So right now my formula, I can say, all right, X over the sine of 26 degrees and 50 minutes is going to equal 101 over the sine of alpha. So all I have to do is get alpha, and then I'm ready to set it up. How am I going to find alpha? Well, let's think here for a second. You all kind of watch really closely here. when I do that slope of the mountain, no matter where I'm on that mountain, the slope is always 2240. So like even right there is 22 degrees and 40 minutes. Okay? Right here is 22 degrees and 40 minutes. Right there is 22 degrees and 40 minutes. Well, look, if that forms a right triangle, and if that is 22 degrees and 40 minutes, I can get, we'll call this one gamma. I can get gamma because it's just the difference of that and 90 degrees. So gamma is just going to be 90 degrees minus 22 degrees and 40 minutes. Okay? So gamma, if I rewrite 90 as the 89 degrees and 60 minutes, so I can subtract. So 89 minus 22 is 67 degrees, and 60 minus 40 is 20 minutes. Okay, so really, then to get alpha, what I'm going to do is let me get another color so I can do all this and side work in different colors for you. I know alpha plus gamma, which is 67 degrees and 20 minutes, plus all that other angle, which was 2650, all of that has to add up to 180 degrees. So do 180 and subtract the other two from it, and we'll be good to go. When I just quickly do the math on my own, then I get alpha to be 85 degrees and 10 minutes. I said 10, but I actually meant 50. It's got to be 50 degrees. So, or 50 minutes, sorry. Okay, so that's what alpha is. Let's go back to our problem. Put this in, and then we can call this done. So x is going to be 101 times the sine of 26 degrees and 50 minutes, all divided by the sine of alpha, which is 85 degrees and 50 minutes. All right, last but not least, we can plug this all in our calculators real quick. And my thoughts are kind of to round it possibly to like 3 significant digits. So with all of this, I'm getting 47.7 feet for the height of that watchtower. Seems pretty reasonable for a watchtower, you know, 47 feet. If every ceiling is roughly a 12-foot ceiling, maybe a four-story watchtower, doesn't kind of make sense. Okay,